Okay. All right. So let's consider this very simple XML file. Notice that it has a document declaration here that it's an XML document and how it's being encoded in UTF-8, right? And it doesn't depend on any other document, so we don't need any interpretation. This particular XML document is not going to be validated against any schema, right? It's a standalone file, right? That has no dependencies. And we see that the schema is that it has a root element of students, okay, and then internally has 2 student instances stored in there, right? And each student has a field such as first name, last name, and username, and one attribute that defines the ID of the student 123 and 234. Right? It's a very simple XML document. So we're going to be using the Java's DOM manipulation library, right? That are found under javax.xml parsers, so the document builder and document builder factory and document builder that allows us to manipulate in DOM objects, document object model XML documents. Okay. So first we're going to open up an XML file. Might as well do this. Let's see. Let's switch here. Let's close all these. And under XML lecture, let's create here a file. Let's create a Java class, and we'll say call it read XML file. And we're going to put it under CS5200, and we'll do XML. And we're going to we're using the DOM. Right, and we'll put a main function there. All right, we'll also perhaps create an XML document in here, new, other XML document, XML file, and we'll call it students.xml. And I'm just going to copy it from our example here. There we go. All right, so we have an XML document. In our file, we'd like to be able to open it up and interact with it. Just read things from that one XML document. So let's load all these libraries. Right, so that's let's remove this, and this would be instead of import javax.xml parsers, and we'll load these two. Document Builder Factory and Document Builder. So they're both under there. And we're also going to load the W3C is responsible for keeping the standard, the XML standard, right? And they provide their own representations and implementations of of the XML and how it's being parsed and represented in Java, right? So the tree that we saw earlier. Right, they'll all be considered to be nodes of this tree, right? And these trees are of different types. I mean, some of these nodes represent the elements in the XML document. Some nodes are representing the data in that XML element, right? Or they represent the attribute, right? So each node has several satellite information around it, right? It could be an attribute, it could be data. Right, or it could be the element itself. Okay, they're all considered to be nodes in this tree. Okay, so we would need to get a hold of the node or a collection of nodes. Right. So for instance, in this particular case, these students, right? These students under the parent graduating students, they're all a list of nodes, right, that can be retrieved from the parent. Elements. Same thing for course. These 3 courses would come back as a list of nodes when we ask for the course list. Okay. All right. So let's keep going. We can then ask: is this an element, right, or is it an attribute, or is it actual text, right? And then they can be converted or cast into the right data type before we can interact with it and retrieve any of those data inside of that particular element. Right. So let's load these libraries in here. Let's import all these libraries in there, all these interfaces in there, and let's also load the file IO so that we can read the file itself. Okay. All right. So first we'll make sure that we either throw the exception or we handle any exceptions due to as we are parsing or opening files. And I think I have an extra tab in here. There we go. Right, and then here we can ask the document builder for an instance of a document factory that we can then use to parse the XML file. And the document builder will be the interface that will allow us to actually start interacting with the file. Okay, we can then read the file location. In this case, it's inside of source, inside of CS 5200, inside of XML, inside of DOM. Right? In Java, the package maps to a directory structure, right? So here, the students.xml is inside of CS5200/XML/DOM inside my source directory, right? And source is a top-level directory in my project, right? So this is this source is this source directory right here, this source over here, okay? It's relative to this source over here. All right, so once we have that, we can then parse the XML document, right? The XML file which we just opened, and then alternatively we can normalize. Now this means that any extra spaces, extra tabs, white spaces, any C datas, any comments. Any of that extra information that is not part of the actual information, right? It's just going to be removed, right? It's not needed for the data model representation, right? So we can normalize that and remove all that, and once we've normalized it, we can then start interacting. For instance, we can retrieve the very top of the document. We can retrieve the this element over here. Am I missing something? No, I have an extra parenthesis here. Let me remove it. Extra parentheses there. And so doc, right? Doc is the object that's going to allow us to interact with the document, right? This gets loaded into memory, right? It gets parsed and instantiated in memory, and then we can traverse it by using the API inside of the document. Right, inside of the document object, right? We can ask it, hey, find me all the elements that have this characteristic, right? Using a technique that we'll see a little later, that's XPath, right? Which is the equivalent of SQL, right? Just like SQL has a syntax that you can say, hey, retrieve for me the following fields that are stored in these tables that are referenced this other way, right? That meet this criteria, right? XPath, we'll see it a little later. Right, that is a language that allows us to query, right, document objects, XML documents, right? So find me all the student elements, find me all the course elements, right, and giving it a certain criteria, right? Courses that or grades that for courses that were taken in 2009, right? And then it would traverse the entire XML document looking for elements in the document that match that criteria and return to you a list of XML elements or XML nodes, right, that meet that criteria. Very, very similar to what you would do with SQL, right, by querying a flat set of tables. Yes? Right? XPath does the same thing. We'll see that in a little bit. Okay, so here we have the document. And what we're asking here is we're telling you, hey, document, normalize yourself, and then we're asking get the node names. This is the root. The doc get the document element gets the root element, and we're asking the node name. In this case, it would be the students. This is the root, right? So R it would be the root name. So let's run this as a Java application. And it comes back with just students, right? So it has the root of the document. Yes. We can go a little further, and we can retrieve. We can use doc to query the document, right? We can query the entire document. We can say, okay, fine. I have the root. I can also from the document ask things such as retrieve for me all the elements whose tag name is student, right? In this case, they're all here, right? There's one here, there's another one here, right? And as many as I would have, right, it would come back with all the elements that have that name, right? But now that they could appear anywhere in the document. Here, they appear as siblings, right? At the first level of this tree, yes. But this would traverse the entire XML document looking for all the elements whose name is student, even if they are embedded, way into some kind of embedded hierarchy, very nested inside of the XML document. Yes, we would retrieve them as a list of nodes, right? So this one returns a list of nodes. Right, so let me declare this. There it is. So this comes back as a list of nodes, which I can then iterate over. I can just go over each one. I can get the how many elements there are, right? Getting the students.getLength, and then I can just iterate with a for loop. I can say for loop on student count, and then get each one of the nodes. I can get each element at the item at the location sub I, and get each one of the student nodes. Yes. Again, these are not necessarily contiguous nodes. Right, they could be spread all over the document, right? In our document, it happens to be all at the same first level, okay? So anywhere they would appear, you would get this node list, right? A little bit like jQuery. I don't know if you've done jQuery in web dev, right? If you give it a particular ID or a particular class, right, wherever they would appear in the document, you would get an array of elements in the HTML document, regardless where they appear in the HTML document. And then you can iterate and transform them one by one. Same thing here. Okay? That's why jQuery is called jQuery, right? Because it allows you to query the HTML document. Here, we're going to be using XPath, right, a little later. All right, so we have the student node. We can ask what type it is, get its type. Is it an attribute? Right? Is it a text node? Is it an element? Right? Is it a tag? What is it? Okay. And then we can decide what to do with it if it's an actual node, right? If it's an element node, right? Which is a static value constant inside of the node class, right? If it is, then I can safely cast it into an element, so that I can use some of the APIs for the elements, right? Such as getting its attribute. Getting its child text that is embedded inside. I can do all sorts of things, right? Once I have the element, I can get its attribute. There it is. I can get the attribute, right? Because notice that student has an ID. There it is. I'm going to retrieve that 1, 2, 3. So I have the ID now, and then I can retrieve the nodes, the child nodes inside of the element, right? Inside of the student element, because the student element has several sub-children, right? The first name, last name, they themselves are, each one has its own node, right? So I can retrieve any children from there by the name, their names, right? Starting at the student node, right? So starting at the student node, here's a student node, right? I can get the elements by tag name. This is going to, the get elements, notice that it's plural, get elements. This always returns a list of nodes. Right. Since I know there's only one of them, right? Under a student, there shouldn't be 2 first names, right? Or 2 last names. That makes no sense, right? Since I know the schema, there's only one of them, I can safely say that I want the first one, right? Item sub 0, right? And then get that first name node and last name and username. So let's grab that. Let's grab them, all of them, and let's bring them all here. And why is this not formatting correct indentation? Oh, there we go. There we go. So we got the 3 nodes for the username, first name, and last name, and then we can retrieve the actual values from each one of them. Oops. We can retrieve. We can cast them. Notice I'm not going to test to see if these are actually element nodes, right? I'm going to assume that they are. I wrote the document, so they should be. But a good practice would be to always check and verify that indeed these are all elements. So let's grab the first name, last name, and username as elements. Once we have the elements, we can retrieve their text. We can retrieve their text and store them in local strings, and then just print it out for. I think I named these differently. First name element. Let me remove the element here. There we go. First name, last name, and username. And now we can iterate over them and just run it. And there we go. So we got the values for Alice and then Bob. All right? But this is way too low level. Right? This is way too low level. And it's also very time consuming. It's error prone, right? It's like trying to write another language from another language, right? It's just very hard to do. Ideally, there would be a way to automatically say here's the data model for Java, here's a data model for XML. Do the mapping, right? Following some conventions, right? So, for instance, we could imagine that this XML document would be, we could certainly extrapolate that this could be converted into a table of students, where each record is represented by each student element here, yes, and there would be 4 columns, right? There would be an ID column, there would be a first name column, last name column, and username column, right? And that would be the schema, right, for a SQL, a relational schema, right, that we could represent this and capture this in a relational data model, right? And we can also extrapolate and say that this could be mapped to a Java class, right, where you could have maybe a Java class called student that has attributes or properties ID, first name, last name, and username, with their own setters and getters and constructors to instantiate these folks, right? Plus, there might be a separate class of students, right? But that might contain a collection of students. Yes? Probably formatting those or capturing those 2 classes. A student list, right? And then maybe a student instance in 2 different classes. Make sense? So let's play around with that idea. And we'll do that in the next. We'll do that in the next lecture.